Over the years, no matter who you are, you've probably heard about terms like a particle accelerator or quantum physics as exciting new ways that we can change our world forever. But be honest, have you ever heard of an interesting development randomly which seems so groundbreaking and then never heard about it again? This is one of the biggest problems that theoretical physicists are approaching, and it may lead to a staggering halt for this field. But through all these issues, there's a fundamental problem lying at its center, which is the root of all our problems. Okay, so actual progress in the world of theoretical physics has slowed down at a very fundamental scales. Basically, ever since the confirmation of the Standard Model in the 1970s and 90s, ending with the Higgs boson discovery, there have been no new fundamental particles discovered. Now, this could honestly mean that we found them all, but theoretical physicists have had issues with this problem, and to combat the lack of progress, they started creating more theories with lack of experimental anchors. Basically, theories started to lack real-world implications, and tests were not able to find decisive or maybe even remote real-world implications of these theories. Now, we come to one of the fundamental problems, which is the reason why these theories have been so problematic, and it stems from the core of physics. Let's go all the way back. When we think of historical physicists, we think of an apple falling on Newton's head, helping him discover gravity. Basically, we look to the real world for anomalies and try to explain them. That is the core of physics. Physicists regarded math as a tool to help us model our world. However, since the introduction of electromagnetism, everything has started to seem way more abstract than before, when physical models were easy to be observed by all. But the introduction of quantum physics has really changed everything for us. Things were advancing faster than our brains could process physically. This is why physicists started getting accustomed to not seeing physical proof early and started relying on unobservable entities to explain forces. Wait, so what is the fundamental problem here? Math. Over time, math has started leading physical discoveries instead of supplementing it. When our math seems to predict something strange, physicists immediately call this a theory, even though there is no physical proof. This fundamental issue is so deep-rooted in physics culture that physicists don't even realize it exists. So what are the steps we should be taking forward in theoretical physics to solve this? Honestly, this shift isn't as bad as it seems for two reasons. One, once physicists start realizing that these ideas are not worth committing to, they are definitely smart enough to start focusing on the things that are really important, real and meaningful experimental work. Two, because these sort of walls in physics are common. It's pretty hard to always have breakthroughs, but that's what the corporate world who are funding scientists want. Overall, in some times, we will be able to break through this wall and start creating real and meaningful discoveries. Physics has been one of the greatest gifts to humanity. We rely on it every day. All the technologies of today are based on at least some level of theoretical physics. I am proud of the scientists today, and I'm sure we will be able to break through this issue pretty quickly. If you guys like this video, consider subscribing. It helps me make more epic videos like this as often as possible. Be curious like a child, the world needs more of it. Bye.